Hey Professor, just doing my video real quick to explain my whole situation here. Gonna swap hands so I can move a bit better. So for number one, my logic was using the lens formula, basically just going through the motions of that. It was a converging lens, so I was fairly confident it was a real. I pretty much showed all my steps here. I think it's relatively apparent, but if not, it was the object distance versus the image distance added together equals the focal length, so well, I mean, I showed all my work. I think it's sort of apparent for that. Then I did the magnification, which was m over negative di over do is equal to 60 over 60, which would just be 1. So the magnification was the same, and yeah, that means the image was real, same magnification, and 60 centimeters away because there's no magnification. Object placed on a 10 centimeter placed 10 centimeters from a convex lens with a focal length magnitude of 20, and the magnification was 2 for similar reasons. Just did out the math. I mean, yeah. I skipped 3 and 4 because that's the 2 I decided not to do. For number 5, I basically wrote down, I think I got this a little bit wrong after reviewing things later, but the way that I thought it out in my head was that I basically remembered the bit about how if the angle is not going through the field immediately, like, so B is going straight into the page according to the question, right? So my thought process was I remembered something about an angle issue, but I also couldn't remember exactly what it was, so I thought it for some reason had something to do with surface area. And since 1 and 3 were both going straight through, I imagined that the 2 spinning would be the only one that would get interacted with at all. For 6, it was just multiple applications of right hand rule, so started off with that. Then that obviously creates the opposite. Then A was clockwise since it's going out, and C was counterclockwise because of maybe I got that wrong. But regardless, it's right hand shenanigans. For number 7, the two beams of coherent light, it was a constructive interference, is the sum of the wavelengths, so I said whole number of multipliers of wavelengths. Destructive is the same but opposite, so when they go against each other, and that would be of half wavelengths and an odd number, presumably because one of them would be ahead of the other by a little bit. That's why it happens in the first place. Then for the number 9, I said 136 for math reasons. Just Snell's law. A couple of times back and forth, eventually reaching solving for the sine right there. And since it was 1 over sine, it was inverse sine, so that's how my math worked out. Number 10 was... Sorry, hand's a little shaky. Trying to get you a better view. Basically, similar thing, Snell's law equation, and then I just put in sine theta 1 is equal to 1 over 0.5, and then inverse sine of 0.666 repeating is 4181. So that's how I got that. For 11, I really couldn't remember all that much about how that particular one worked, so I basically just said right hand rule, force current. I had no idea if I got that right, and like it says on the paper, 12 is just a complete guess. I had a 30 chance, so I just went for it. With the Kirchhoff loop equation, I actually took electrical engineering 101 last semester, so I kind of already had a good idea of that. Since these were irrelevant, I just put in exactly that right there. V1 minus I1 R1 minus V3 plus I3 R3 equals 0 because the end result will always be 0. For problem 2, I was really running out of time at this point, just kind of panicking. That's why I guessed on 12. But for the first part, basically I just said it's resistance over voltage is equal to amplitude.